All right, how's everybody doing? You should be able to see my live stream now. Hopefully it's up and running. If you can see it, please go ahead and talk to me in Teams and let me know that you can see my live stream. Hi Aish, how are you doing? Ross B, Sari now, good to see everybody. So, if people can hear me, please talk to me in Teams. Justin McDuffie, can you hear me? It's in the... Can you folks hear me? Yep. Can you folks hear me? I'm talking in YouTube right now, Justin. Are you not hearing me? Okay, good. I'm trying to find out how long the delay is so we can see how this system works. Okay, let's see. Cool. Oh, hold on. Let me close out all these stuff I got going on here. Okay, was it really that long a delay? Okay. All right, fantastic. Well, then I'm going to go ahead and get started. Can everybody see the YouTube screen? You can see the PowerPoint presentation that I have here in front of you. That's okay. That's okay. This is new, so I just want to make sure I've got it right. Fantastic. Well, it is great to see everybody here tonight for the review session. All right, refresh the screen now. Much better. Okay, I'm sorry. The problem was Microsoft Teams automatically opens and it was hiding on my desktop open, eating up my CPU usage. Okay, so we're much better now. I'm going to... All right, my microphone is off on Microsoft Teams, and I'm now just on YouTube. Fantastic. Sorry about the little delay getting started. It's 8:06. We're just a couple minutes late. Let's go ahead and talk about the exam for tonight. I'd like to thank everybody for coming. If you do want to ask a question, just say, hey, open your microphone and say, hey, professor, I have a question, okay? And then I can stop and answer your question. If you want, you can type in the YouTube chat bar, or you can still type in the Microsoft Teams chat bar. I've got both of those chats up and open as well. So you can either ask me a question or you can type me a question. It's all up to you. Does everybody understand that? And if I could get a yes. Okay, fantastic. You're about 3 seconds behind. All right, cool. So the review is, the exam is going to be 60 questions. The exam is 60 questions, multiple choice, matching, and I think there is one short answer. There's some true, false, some matching, and some multiple choice. I'm giving you a little bit extra time for this exam, 90 minutes. I had some students that might need some international students that might have needed a little bit of time, so I gave you a little extra time, 90 minutes. I may dial that back for the second exam to around 75. but hopefully that'll be enough time for you to get the test done. You are not supposed to take the test with your notes or books. I can't necessarily catch you, but I'd appreciate you try to do an honest job for me. Okay, remember, education is all about you trying to learn something and get better. And so if you cheat, you're really not helping anybody, and you're hurting your own self. Okay, so 60 questions. What I'm going to do is I've got a PowerPoint presentation. It is also located on the announcements page of Blackboard, and you will be able to access the PowerPoint presentation that I'm going to go through. It's the highlights from 4 chapters worth of PowerPoint presentations. While this does not represent every possible question on the exam, I'm trying to hit the high points just so you'll know what to look at. Does everybody have a question? I mean, does anybody have a question? Is everybody okay? All right. So, if you look at the chart from chapter 1, I am definitely going to want you to know the broad schools of thought. Remember, these are the unofficial schools of thought that developed before psychology became professionalized after World War II. These represent different ways of looking at the human being, and I promise you there will be questions on the behaviorist approach and the psychoanalytic approach, okay? It's listed right here on the chart. What I might do is I might say, hey, this researcher was interested in understanding how human beings learn and change their behavior. He did a lot of his research on animals, and I might expect you to say, oh, wow, that's probably behaviorism and John Watson, okay? So if you'll look over here, I've got Psychoanalytic School of Thought by Freud and the Behaviorism School. There are a couple of questions where I ask you to identify these 2 different approaches. So be able to distinguish how they differed in their interest in studying of human beings. Okay? This test will be available on Blackboard, and it will be available all day until tomorrow night at 11:59. You must complete this test by 11:59 p.m. tomorrow night. Okay? So, I'm noticing nobody's using the audio chat. Is that because you're not, just out of curiosity, I'm trying to figure out how you folks use this. Do you have a preference of typing rather than speaking? I'm just curious to find out if this, what value, if any, this setup provides to you. Kirchhoff? What do you mean? Okay, let's see. Sub-schools of thought. All right. Now, also from excuse me? Okay. Yeah. I'm seeing the problem. Cut your microphones off. Okay, I'm seeing the problem. Okay, never mind. All right, we'll carry on without this. All right, so from chapter 1, I'm going to want you to know the difference between a correlation and an experiment. There may be a question on the survey or observational method, but I want you to know that correlations demonstrate relationships. So chat. Okay, is lagging the whole. So is YouTube still lagging for you folks? Okay, so we'll know correlations. And then I want you to be familiar with Microsoft, with the experiment. And I want you to know that the most important part of the experiment is random assignment. I'd like for you to be familiar with how you create random assignment. Okay, yeah. You acknowledge it a bit later. It's lagging. Okay. Good enough. Then I shouldn't have done this. Okay. Good enough. All right, so that's what I want you to know from chapter 1. Okay, I want you to know the areas, the subfields of specialization too. Oh, excuse me. And do you remember when we talked about the different subfields of psychology, and I talked to you about what developmental psychologists study, what clinical psychologists study, what industrial organizational psychologists study? I am going to expect you to be able to identify examples of those kinds of psychologists. All right, so I'll give you a question. I'll say, Dr. Smith is interested in understanding how the neurotransmitter dopamine functions in the fear response. What type of psychologist is Dr. Smith? And you would say, oh, he's probably a biological psychologist, okay? So that's how you would do that. I'm going to have probably 3 or 4 questions from this chart alone. So please focus on this chart. Okay. Also, so that's chapter 1. For chapter 2, I do want you to know how the brain and spinal cord are different from the rest of the nervous system. Remember, the brain and the spinal cord are the decision-making parts of your nervous system. I do have a question that asks you to know the difference between the central nervous system and the peripheral nervous system. Okay. Okay. Also, let's see. I do have questions on the anatomy of a neuron. So I'm going to want you to know the different parts of the neuron. You'll see a picture right here: dendrite, cell body, axon, and the terminal buttons. I will ask you definitional questions about those. I do not have any hotspot questions on there, so there will be yes, this video will be available to watch later. So there will be no hotspot questions. You'll see this is the slide for the dendrites, and there's a definition on this. Each of the 5 slides has a definition of what the dendrites do, what the cell body does, what the axon does, and what the terminal buttons do, and what the synapse does. You should be familiar with those. Also, I do want you to know about neurotransmitters, how they function to make neurons either become excited. They're either excitatory or they're either inhibitory. I want you to know the difference between excitatory and inhibitory. And I'll be quite honest with you, I'll probably ask you questions about serotonin, dopamine, and GABA. So I might say this neurotransmitter is important for emotional states and moods. And you'll go, oh, it's serotonin. So I do have 2 or 3 questions on neurotransmitters. Okay. I have one general question on the endocrine system. And basically, I want you to know that hormones work systemically rather than locally. All right, they work just like neurotransmitters, but they course through your entire blood system, okay? Any questions so far? Does anybody have any questions so far? Please feel free to type. It shouldn't be buffering anymore. I'm down to 10% on my CPU usage, so it should be going fine. Any questions? Go ahead. You should not be using your notes. You'd better not be using your notes. It is an honor code violation to use your notes for this exam. You know, the only question I would have about an action potential is that it's a brief pulse of electricity that travels down the length of an axon. I'm not going to ask you to understand the physiology of voltage gate channels and sodium and potassium ions. In fact, I don't even know if it discusses that in your textbook. So it would just be a general question about what an action potential is. How does that sound, Keelan? Okay. I do want you to know the concept of connectivity and modularity, right? So I told you that the brain is not one big complex computer. It's almost over 100 small computers each doing a very simple task. And the power in the brain comes when you connect these different modules together using myelinated axons. The test is timed and it's a 90-minute test. Okay, then what I am going to have are definitional questions on about 14 parts of the brain. I do want you to know these 14 parts of the brain: the substantia nigra, the pons, the medulla, and the cerebellum. And I'll ask you questions like this. Fred has trouble staying balanced and can't walk without falling over. Which part of Fred's brain was damaged? People who have drug overdoses sometimes quit breathing. What part of their brain is damaged by the drugs that they take? So do you understand how I would ask those questions? So you've got 14 brain areas you need to know for this exam. Now the weird thing is we're going to keep going back to these brain areas. So at the end of the class, you're going to know all 14 or 15 of them. But right now it might seem a little overwhelming. But be sure, please try to remember all the different functions of these areas of the brain. Okay? Then there are more forebrain structures. Hypothalamus, I do want you to know that. Questions about specific examples from the textbook, like the feral child. There is one feral child question, and it's just a general question. I'm not sure what the context of that question is. But I did mention the feral child, so I think that's important for critical periods. I think I talked about, it's a critical period. If you don't aren't exposed to language by a certain point in your life, you actually lose the ability to speak or to develop language normally. So I do remember in chapter 4 we talked about critical periods as being a time when your brain has to receive some stimulation in order to develop normally. Okay? Serotonin, dopamine, switch it to 125 speed, it will catch you up. So, can you explain the difference between serotonin? Serotonin is a mood regulating neurotransmitter. Dopamine is an arousal related neurotransmitter that is sometimes implicated in schizophrenia. Okay. And GABA is an inhibitory neurotransmitter that is sometimes implicated in people with anxiety disorders. So I do want you to know those three things. Kircho, so you actually, if you speed it up, it will catch up. That's an interesting thought. Okay. All right. So if you'll look here, we have the cerebral cortex. I do want you to know these areas of the brain. So there's 3 areas in the frontal lobe I want you to know. The prefrontal cortex is responsible for impulse control, planning, and personality. Broca's area is for language production. And the motor cortex moves your body. So I might ask you questions about those 3 areas. So I could use the example, Phineas Gage had an accident at work, and as a result of this brain damage, his personality changed. Which part of his brain was most likely damaged? And you'll say frontal lobe. Okay. Okay, temporal lobe. I'm just going to want you to know that the temporal lobe is for memory. You have an auditory cortex there, which processes sound. And I want you to know about that fusiform gyrus, which allows you to recognize faces. So that's 6 more areas. And then I want you to know the parietal lobe is responsible for your spatial sense. If you can point to where your car is parked relative to where you're sitting right now, your parietal lobe is working. So for me, my car is that way, is right over there in front of my house. I'm facing the front of my house, and I know my car is over there, so my parietal lobe is working. And then I want you to know that your sensory cortex is in the front part of your parietal lobe. And then I want you to know that your occipital lobe is responsible for vision. Any questions? Any questions? Yeah, go ahead and there's maybe a general question on what the global workspace model is. I do want you to be able to do the split brain patient game. All right, so if I take a split brain patient and I show them a picture of a house to their left field of vision, can they tell me it's a house or not? Yes or no? Can they tell me it's a house? I'd be curious to see if anybody knew. Can they tell me if it's a house? Okay, I'm going to go on. Wondering why it's so laggy tonight. Okay. I do want you to be able to know the difference between the sociocognitive theory and the dissociative theory of consciousness. There's a question. No, just a chicken. Very good, very good. Okay, you folks understand. So the information on the right side of the visual field goes to the left part of the brain, and the information on the left visual field goes to the right part of the brain. The right part of the brain can't speak, so if it can't communicate with the left lobe, then even though your right part of your brain sees it. Now the crazy thing is, if I ask you to point to an object related to what you see, your right brain will be able to point. It knows what it's seeing, but it just can't say it, okay? Question about hypnosis. And there's a couple of questions about flow. I think I have a question on the kind of personality that most likely to experience flow, and just a general question on what the flow experience is. Any questions so far? That's chapter 2. Chapter 3. Okay, couple more brain parts. Number 1, there's a general question on the circadian rhythm. Okay. I want you to know what biological processes are controlled as a part of the time of day. And I want you to know that the Right. Okay, a couple of good questions. Number 1, the global workspace model. Basically, the question is, what is consciousness? And I suggested to you that consciousness is sort of this inside representation of all the sensory experiences that are occurring outside of you. And where is consciousness? Well, it depends. Consciousness is put together of lots of things. So depending upon what's got your attention, your consciousness moves about your body. So sometimes you get headphones on and you're focusing on the music, so your consciousness is in your temporal lobe. Sometimes you're thinking about who you are and how you feel, so your consciousness is in your frontal lobe. Sometimes you're playing a musical instrument or a sport and you're not thinking about anything other than body movements, so your consciousness is kind of in your motor and sensory cortex. So the global workspace model says that consciousness is kind of this weird spread out attention activity that moves all around your brain. And Brady asked the very good question, do all people have this difficulty? The weird thing is, or not the weird thing is, but for most people who have a corpus callosum, Brady, the left side of the brain can talk to the right side of the brain. So even if I take you, Brady, a normal person, and only show you a house in your left visual field, it's going to go over to your right brain, but your right brain is going to be able to communicate with your left side. So you would be able to say the object, even if I showed it to your left side. That's because I didn't cut your corpus callosum in half. Does that make sense? I hope that makes sense to you. Okay, hypnosis. There's a couple questions about flow. Sleeping and dreaming. You need to know about the suprachiasmatic nucleus. If you destroy the suprachiasmatic nucleus, all periodicity in your sleep will go away. You'll start sleeping like an infant, right? Up for a couple of hours, asleep for a couple of hours, up for a day, down for a day. You won't have any 24-hour cycle. Now, there is a connection between your eye and your suprachiasmatic nucleus, which keeps your 24-hour cycle tied to the sun. And I told you, if that link between your eye and your suprachiasmatic nucleus is damaged, then your cycle will change a little bit. It will get a little bit longer, so you won't be tied into the sun as well. And so they suggest that people who are blind have a greater likelihood of having sleep disorders than people who have sight. Okay? Now, I do want you to know the suprachiasmatic nucleus. I do want you to know the pineal gland produces melatonin at night, which is the sleep hormone, okay? There is a question about melatonin, there is a question about the suprachiasmatic nucleus, and there is a question about the biological processes that change based on the time of day. So sometimes you're awake and sometimes you're asleep. Cortisol level is at higher production during early morning and late afternoon, or like in the early evening, than it is late at night or midday. Body temperature fluctuates throughout the day, and your need to produce urine varies throughout the day. So I do want you to know those biological changes. I promise you there are 3 questions off of this slide alone. Okay. Also, the EEG recordings. I do want you to know the different types of brain activity associated with the different areas of sleep. Remember, I suggested to you that we engage in non-REM sleep and REM sleep. All right, non-REM sleep is divided into 2 parts, light non-REM sleep and deep non-REM sleep. When you're in light non-REM sleep, you have sleep spindles, complexes, and theta waves. When you are in deep sleep, you have delta waves, and your brain is really working slow when you're in deep sleep, okay? You dream when you're in REM sleep, right? And you sleepwalk and sleep talk in deep sleep. All right, so keep that in mind. A lot of people get tricked up because they think people sleepwalk or sleep talk because they're having a dream. Actually, you're not. It's a completely different experience, okay? I think there might be a question or two about the cycling back and forth between REM sleep and non-REM sleep at night. You get most of your deep sleep early in the night. You'll see down here in the gray area, you get the most of your deep sleep early in the sleep cycle. And then we dream towards the end of the sleep cycle. See how we have more REM sleep as the person gets closer to waking up. Does that make sense? We spend 50% of our sleep cycle in stage 2, slow sleep. I think there's a question about that on the exam. Okay, sleep disorders. Let's see. Sleep disorders. I do have 2 or 3 questions on sleep disorders. Insomnia is just when you have difficulty getting to sleep. Sleep apnea is when you have trouble getting enough oxygen while you sleep, and your medulla, remember your medulla controls your heart rate and breathing, wakes you up in the middle of the night so you can gasp for air and get enough oxygen. It measures the level of oxygen in your blood. And so people with sleep apnea usually have obstructions which keep them from getting enough oxygen at night. So they wake up hundreds of times a night and feel sleepy in the morning and don't know why. Okay? Remember, narcoleptics are the ones who have the abnormal sleep cycles at night, and they don't get enough REM sleep. So these people fall directly into REM sleep in the middle of the day. I'm not sure if I have a question on REM behavior disorder, but those are the people whose bodies aren't paralyzed by their pons when they're sleeping. If you'll remember from chapter 2, I told you that the pons is responsible for sleeping and waking. We revisited again in chapter 3, and I tell you that it's responsible for making your body go flaccid while you dream. People with REM behavioral disorder thrash around while they're dreaming. Okay, and remember, sleepwalking and sleep talking, it's fairly common in early childhood, and it is not a REM sleep event. Any questions? Any questions? That's chapters 1, 2, and 3. Okay. I feel like nobody's asking any questions. Is that because I'm boring you, or because you're focusing and getting all the information, or you already know all this stuff? Is there anything I can do? It's weird when I'm not getting any feedback. Okay. Well, I'm assuming you're all doing all right. Okay. There is a question. I want you to be able to put the 3 prenatal development periods in order: germinal, embryonic, and fetal. I want you to know what generally happens in these 3 stages. The germinal period is when that fertilized cell floats down the fallopian tube and implants in the uterine wall. As soon as the neural groove starts developing, the nervous... Yeah. Okay, so maybe if you're going to talk, I've got one more problem to figure out. So you can't talk because my YouTube is running in the background and making noise. Okay, all right. So why are we so far behind? Can you folks hit the YouTube and move it all the way up to Israeli Dave is kind, just so you know. Okay, cool. Well, this experiment is not working. I thought I could put these 2 tools together and get something really powerful, but it's just not ready yet. So I'll go back to the old way of doing it. I apologize for anybody who's been inconvenienced tonight. I apologize a bunch. Okay. While live streaming on the YouTube. Yeah, I'll have to think about that, Michael. If I do that, then the people on YouTube, the recording, people won't be able to hear the recording when I'm done, Michael. You know what I mean? I've still got some details to figure out here. I'm on to something. I just got to figure out how to make it work. Damn it. I'm sorry. I feel so bad sometimes. Okay, so the embryonic period, I want you to know that all the organs begin to develop begin to develop in the embryonic period. Organogenesis occurs there. That's when all the organs begin developing. Now, remember, the green line is when they're most susceptible to a teratogen. That's an external substance that can damage them. But they're not done as long as that purple line's going on. And so what I do want you to know is that the human nervous system is not done until you are 25 years of age. But the embryonic period is when all these systems are developing and when they're most sensitive to teratogens. I was at the grocery store today and I saw a fellow whose hand was attached to his upper arm. His forearm had never grown. His forearm had never grown. And so he had a claw hand that was actually attached to his elbow. Yeah, you can do it in the old way. I was trying to make it better, and so that guy probably had a teratogenic substance during this embryonic period when his arm was forming. And so his arm didn't form completely. Okay? Do you have birth defects associated stage? About that side, why do you have birth defects and miscarriage associated with these stages? Well, typically, here's the deal. The nervous system is your body is trillions of cells being created and moving to the right place. And you have these genetic instructions that cause you to unfold. And a lot of times, if you have some sort of major genetic or chromosomal problem, your instructions are such that the body doesn't start growing right. And this is why you have the miscarriages during these first 3 to 8 weeks, because this is when the system is creating, when the prenatal development is creating the major systems of the body. And so sometimes the body doesn't design itself right. The heart maybe grow outside of the body. Anencephaly occurs. Sometimes a brain just doesn't grow. And so what typically happens is the fact that you have more miscarriages during the first trimester is because that's when these organs are forming, and that's when sometimes Mother Nature says, uh-oh, this baby isn't going to be viable, and so the baby is miscarried. I hope that makes sense, right? Let's see, fetal period, most weight gain. I want you to know that a teratogen, when a teratogen affects a baby, it depends on the timing, the amount, and the genetic susceptibility. So if we look, let's see, arms begin developing in week 4 and are finished by about week 9. Do y'all see that? The gentleman that I saw today whose forearm didn't develop, he may have had a teratogen exposure at 6 or 7 weeks. And that caused whatever genetic instructions that were supposed to grow him a forearm, not to grow him a forearm. And then when his hand instructions started building his hand, there was no forearm to put it on. So his hand was sort of attached to his elbow. A teratogen is any molecule that can pass through the maternal blood barrier. Remember, the placenta is a filter of sorts. The mother's blood does not touch the baby's blood. They do not mingle. Instead, the blood vessels go side by side, just like this. And between your cells, you have these spaces, these interstitial spaces, so small molecules can squeeze between the cells of your capillary. So what happens is salt, water, and oxygen and small molecules can diffuse from the mom's blood into the baby's blood so the baby can feed and eat and get the nutrition that it needs. And then the wastes from the babies filter through into the mother's blood system and is carried away. And big molecules that would damage the baby are blocked from getting through this system. The only thing is, there are some molecules that are small enough to pass through this blood-brain barrier, and those are the ones that damage the babies, and those are the ones that we call teratogenic. Okay? Do you remember we talked about myelination and dendritic growth? Remember I suggested to your brain changes in 2 ways after birth. Okay, you've got all the neurons you ever need. Instead, 2 things have to happen. Some neurons have to myelinate, and that's a maturation process. It happens basically according to genetic instructions. There's no way you can speed that up or slow that down based upon having a bad life. Okay, and then dendritic blooming and pruning is a result of stimulation and experience. So as you stimulate neurons, they grow together and create crazy connections. We call it excessive blooming of dendritic connections. So your brain overwires itself. But then as you begin to mature whatever behavioral ability, your brain picks one neural pathway that works the best, and the ones that it created earlier begin to wither and die. And so basically what it does is it allows your brain to wire itself together in the way that works the best for your particular brain. Does that make sense? Okay. Now, I do want you to know that myelination does not occur uniformly, and it depends on, it comes earlier in different parts of the brain. So your vision is pretty much mature by about the age of 6 months of age. And so that part of your brain is myelinated by 6 months of age. Little kids learn to walk and talk and remember things before they finally finish their personality and develop impulse control. So you'll see that the motor and sensory area myelinate pretty early. The part of your brain that takes the longest to myelinate is this personality center and this parietal lobe, which is where abstract thinking is going to occur. Okay? Growth is genetic. The growth potential is genetic, Justin. The environment is and the environment shapes that developmental potential, if you would. Okay, so you all have a genetic potential to develop language, but you must hear language in order to develop that language ability. Does that make sense? The brain does not fully myelinate until the age of 25. The brain does not myelinate until 25, right here. In fact, this is why we do not diagnose people with personality disorders until at least 18. It is generally believed that until 18, your personality is still in flux and you haven't developed your final personality. And people aren't good decision makers until they're 25. And this is why, if any of you are paying for your car insurance and you're not 25 yet, you pay a higher rate than old guys like me, because you're more likely to get in a hurry and do something stupid because this part of the brain is not myelinated. Oh, there you go, Keelan. Woo-hoo! 25 years old. She's fully myelinated. I'm so proud of her. Oh, good deal. Telling on yourself. Okay, milestones. Remember, I want you to know milestone behaviors are just behaviors that occur in a pretty predictable time, and they allow doctors to guess whether or not your baby's brain is developing normally. So I can't see the myelination. I can't really see the dendritic spreading without expensive experimental tools. So what I do is I look at the behaviors that should be occurring if the brain is developing normally. And I suggested to you that as a general rule, children's abilities unfold in a very predictable way. And in fact, your book has this chart right here, which gives you a pretty good path for how children develop during the first 2 years. First, they learn to hold their head up. Then they learn to roll over. Then they learn to sit with a little bit of support. Then they learn to balance themselves and sit up without any support. Then they learn to pull themselves up to a standing, they learn to stand holding up. Then they learn to pull themselves up to a stand with their hands. Then they learn how to walk holding on to things. We call that cruising. And about that time, they may cruise or they may crawl around the same time. And then kids start taking their first steps right around the age of 12 months, okay? And so we all have followed this progression. Doctors are interested in this because this allows us to discover whether or not you might have a delay, a developmental delay occurring in your nervous system, all right? I want you to know that gross motor milestones are big muscle movements like jumping or moving my neck, okay? And fine motor movements are things like using my little finger right here to write. And if you folks, and I will tell you that gross motor milestones develop before fine motor milestones. That's why when you went to kindergarten, you used a fat pencil and the paper with the big lines first, because your fine motor muscle control wasn't quite mature at the age of 6 and 7 years of age. And you can rent property too. Yep, you can't get an Airbnb before you're 25, right, Mike? That's funny. I was thinking about that, but I forgot to say that one too. And then we talked about attachment theory, a socio-emotional developmental theory. Remember, Harry Harlow found that the monkeys preferred the soft, cuddly mother rather than the mother with food. If you go back to chapter 1, we were talking about behaviorism. They said we do things only because we are rewarded. And people used to think that children were rewarded by food, the mom's breast, and that's why they love mom, because mom had food. But Harry Harlow found that the infant-mother relationship was about love and comfort as much as it was about food, because the monkeys chose to hug on the soft mother monkey instead of the wire monkey with food. 4 more years before you can run for president. Mike, I might vote for you. What's your platform? Tell me all about it. Okay. Remember, then Mary Ainsworth wanted to know whether or not children differ in their ability to a bond to their primary giver. Were there differences in attachment styles? And she noticed that that babies have these 2 very normal fears. They have stranger anxiety. They're afraid of strangers between 6 months and about 2 years of age. And they also have separation anxiety. They get real upset when their mom leaves. And when their primary caregiver leaves and they experience separation anxiety, they act out with separation protest. They cry, right? So separation anxiety is the fear. Separation protest is the behavior. Now, remember, she tested children's attachment styles by separating them from their mom. And the part that she was interested in was how easily are they able to reestablish attachment once mom comes back in the room. All of the kids cried when mom left. The question was, will kids be able to easily calm down when mom comes back in? And what she found was that 50% of the children were able to easily calm down and go back to normal when the mom came in. She called those secure children. Some of the kids were very clingy and couldn't stop crying and wouldn't let mom go when she came back in the room. Those were the anxious ambivalent children. And some of the kids were actually kind of angry at mom. And when she came back, they didn't want to be held and they didn't want to look at her in the eye. Those were the avoidant children. And she believed, and evidence has suggested, that these infant attachment styles may affect how you behave in adult romantic relationships. Okay, any questions? Jean Piaget. I'm going to ask you to know what the people can and can't do during these 4 stages of development. Children from 0 to 2 do not have symbolic ability, and they can't demonstrate object permanence or objective self-awareness. Pre-operational children are symbolic, but they're not logical. They're the ones that'll believe in Santa Claus, even though Santa Claus doesn't make a bit of sense. Around 6 or 7, children become teachable. So they're in the concrete operational stage. They can think logically, but they're not very good at it because it's a new behavior. So you have to make things concrete, things that they can look at, or things that they're familiar with in order for them to reason logically. And then around the age of 12 or 13, we all become abstract thinkers and we become able to reason logically and abstractly, okay? A scheme is a mental representation. It's the building block or the atom, if you will, of knowledge. All knowledge starts with a scheme, and schemes get more complex. And remember, I told you the story about how schemes can be used. We change our schemes using one of 2 processes. We try to find out where our scheme will work. Can I do this here? Can I do this here? Can I do this here? And if it does, you are assimilating that scheme. So when my kid learned what a dog was, he started pointing at different things that look like dogs. And I told him, yes, that's a dog. Yes, that's a dog. Yes, that's a dog. And he learned that he could use his dog scheme in lots of different places. He assimilated that scheme. But then I showed him a cat and he said dog. And I said, no, that's not a dog because a dog barks and a cat goes meow. And so he had to change his scheme. He accommodated that scheme to new information. So I want you to know what a scheme is and what accommodation and assimilation are. Okay? Piagetian task, remember object permanence is when the little baby forgets about an object as soon as it's hidden from them. And this is because children are really caught up in their senses and their motor movements. They don't really have things symbolically in their minds. So if it's out of sight, it's out of mind, right? And then the conservation task were the logical tasks that children who were 4 or 5 years of age couldn't do. A conservation task would be taking a short, fat glass of water and pouring it into a tall, skinny glass and asking the kid, do you have the same or more water? And a kid in the pre-operational stage will look at the size of the glass and say, the glass changed, so there must be more water. While you, the logical people, would say it's the same amount of water, you just poured it into a different shaped glass. That's a conservation task, and 3 and 4 and 5-year-olds fail that all the time. All right. And remember, hypothetico-deductive reasoning is just being able to figure out what might happen in a novel situation in the future. I've never done this before, but if I do this, what could possibly happen, right? So maybe you've never been in a china shop before, but you wouldn't go into a china shop and start swinging your golf club around, right? Why? Because it's probably going to lead to something getting broken. That's you being able to guess what might happen in the future even before you try it. That's called hypothetico-deductive reasoning, and that's the hallmark of adult thinking. Okay? And then Erik Erikson. I'm going to ask you about Erik Erikson. I told you that all the nursing, nursing students need to know this because this is really popular in nursing school. He suggested that our personality develops in 8 stages, and in each of these 8 stages, we have to resolve a crisis or a psychosocial task that we have to learn. We have to learn to trust the world during our first year of life. The second year, we have to learn how to be autonomous and do things while still understanding no and having a sense of guilt. During preschool, we have to get the confidence up to take a turn, right? That's called initiative. But we also have we have to learn the ability to give somebody else a turn. That's the guilt part of it. When we go to school, we have to learn how to make something good, make good grades, and we learn the difference between writing a good word and a good B and a bad B, or a good L and a bad L. We learn the difference between doing something well and doing something poorly. As adolescents, we're trying to develop a sense of identity, and we have to feel confident picking the kind of person we want to be as a grown-up, right? And then during young adulthood, it's intimacy versus isolation. You're trying to find a gang, a romantic partner, people to be with, right? And then in my stage, middle adulthood, I'm thinking about the future and what my children are going to do and what kind of legacy I'm going to leave. And then in old age, when you get to the end of your life, you have to be able to look back on your life and say, I did a good job. This was a life well lived. That's the integrity versus ego versus despair. And so what I'm going to do on the test is I'm going to give you the example of 3 different people, and you're going to have to tell me what stage they're in. Okay, I like to ask about infancy, and I like to ask about adolescence, middle adulthood, and old age. You should probably be familiar with those 4 stages in particular. Okay, we're running out of time, and I've got a 9 o'clock section, a 9 o'clock review session for my developmental psych class. I am so sorry for the technical problems tonight. Thank you for experimenting with me and helping me to figure out how this works. And maybe it didn't work great, but I'll figure the bugs out. Michael, maybe you can give me a little feedback, or if anybody wants to give me some feedback, and maybe we can try to make this work better. But I envision a classroom where I could be talking to you and you could be talking back to me, and we could have sort of a normal conversation. But maybe that technology's not ready for that yet. Okay, folks. No problem. Thank you. Good luck with the exam. Hey, don't forget to do your homework tonight. Don't forget to participate in the Neuromatrix and get your extra credit. And it is my goal to get your discussion boards graded tonight before I go to bed at 1 o'clock, okay? Okay, I'll do it on Teams and then record it and post it to YouTube. I'll try that next time. Thank you, Keelan. I appreciate you for your feedback. Thanks, folks. Hi, Rat. All right. I appreciate it, folks. You have a great evening. I'm going to take off now.